There are two types of compound inequalities, and or. And compound inequalities overlap their solutions. In order for a compound inequality to be true, the solution must qualify both one inequality and the other. A compound inequality is a sentence with two inequality statements joined by the terms and or. And inequalities act as the intersection of each individual inequality in the sentence. That is, their solutions overlap. We treat compound inequalities just like any other inequality. The only difference is there are two inequalities to plot. So I'm going to start by solving both of them. Solve the first inequality. In this case, I have a one step. I'm adding 3, so I'm going to subtract 3 from both sides. That's going to give me x is less than 5. My inequality did not flip because I did not multiply or divide by a negative value. Now that I've solved it and written my inequality, I can plot it on my number line. It's an open point because it's just less than, not less than or equal to. And to see if I'm going to point left or right, I need to look for true or false statements. You point at a true statement or a point that gives you a true statement, and you point away from a point on the number line or a value on the number line that gives you a false statement. You can use any value. I like to use 0. 0 is greater than all negatives and less than all positives. That makes this true. 0 is less than 5. 0's to the left, so I'm going to point my arrow to my left. For that part of my compound inequality, all the solutions are to the left. Now I'm going to solve the second inequality. You cannot plot an inequality until it's solved. This is a two-step inequality, so I might tell myself a story here. I want to read the inequality in terms of the order of operations. My variable is being multiplied by 2, and then we're adding 4. To undo that, I need to use the inverse operations in the inverse order. I'm going to subtract 4 and then divide by 2. I do that to both sides because even though an inequality is unbalanced, one side's always greater than or less than the other, we need to treat it like an equation. We need to do balanced inverse operations. When I do that, I end up with -9 on the left, this little calculator moment. The inequality symbol did not change even when I divide by 2 on both sides. That's going to give me -4.5. It's okay to get decimals. It's okay to get negatives. 2x divided by 2 gives me x. The inequality started less than or equal to, ended less than or equal to. It only changes when you multiply or divide by a negative number. So now I'm going to plot the second inequality. That's a closed point at -4.5, so I need to kind of estimate. It's going to be between -5 and -4. It's going to be exactly halfway between the two. No one's ever going to measure. We're estimating. In this case, I'm going to compare it to 0. 0 is always greater than any negative. So the inverse of that, all negatives are less than 0. That's a true statement. So I'm going to point at 0. Now I'm going to shade the area where the inequalities overlap. The green arrow can go all the way to the left, but it won't pass the red point. The red arrow can go all the way to the right, but it won't pass the green point. So I'm going to draw in and shade in the area between. So that means all the solutions, including -4.5, all the way up to 5, but not including 5, would make either of these inequalities true. This is why we refer to these sometimes as and compound inequalities. They overlap. All of those solutions would be true for the left and the right inequality in our compound inequality. On your own, solve the first inequality, plot it. Solve the second inequality, plot it. Find where the two overlap. Those are the solutions that make the left and right inequality true. Compound inequalities don't always have the conjunction and or in the middle. Sometimes they overlap into one compound inequality. One of the best ways to deal with this is to turn it into something we know. We know how to solve and then plot individual inequalities. So let's turn this into two individual inequalities that are still compounded. So we separate the compound inequalities into separate inequalities. You go from one side all the way to the second inequality. So the second inequality symbol. So that's one inequality. Negative 11 is less than or equal to x minus 6. We go do the opposite from the other side. So I'm going to look at all the way from the right, all the way up to the first inequality symbol. They're always going to overlap that second part. So whatever that second part is, it'll end with the first inequality and it'll start the second inequality. These are and. So they're going to overlap. Their solutions will overlap. Now I just need to follow the rules we already know. Solve the first inequality. It's a one step. I'm subtracting my variable, or subtracting 6 from my variable, so I add 6 to both sides. That's going to give me negative 5, little calculator moment, is less than or equal to x. I'm going to plot that. It is a closed point because it's equal to, and I'm going to the right because negative 5 is less than or equal to 0. 0 is to the right, so that's a true statement. I point at the true statement. I point away from the false statement. Now I'm going to solve the second inequality. Another one-step inequality. I am going to add 6 to both sides, keeping it balanced. That's going to give me x is less than or equal to 1. Little calculator moment. Notice the inequality did not flip because we never multiplied or divide by a negative value. Now I need to plot the second inequality. That's going to be another closed point. That means that 1 is an included solution. I'm going to plug in 0 or any point. I also could look at it as x is less than or equal to 1. Replace the word x with the solutions, or the phrase, the solutions. The solutions are less than 1. So 0, negative 1. Those are all true. Those all are solutions that are less than 1. I'm going to find where those values overlap. So my actual solutions include negative 5 and all the way up to and including 1. Those values would make either negative 11 is less than or equal to x minus 6 and x minus 6 is less than or equal to negative 5. It would make both of those inequalities true. On your own, try solving and then plotting this inequality, this compound inequality. Remember, it helps to turn something we don't know into something we do know. Try splitting this inequality into two separate inequalities. Look to see if it's a one-step or two-step inequality. Solve it, plot it, and find where the solutions overlap. The solutions that make both inequalities true.